Hi, I'm not Rich Welsh.
And I'm not Polly Hickling. And welcome to our final John Logie Baird session for today.
AI in Media Revisited is an update on our talk from 6 months ago.
You weren't making deep fakes of us last time. Inappropriate. And being on an alien planet?
Haven't you always wanted to be in Star Trek?
Okay, I admit that that's true.
We could do this all day, but maybe we should introduce the real us.
Good idea. Please welcome to the stage the real Rich Welsh and the real Polly Hickling.
God, that was cringy.
It's so much worse.
So, that's what happens if you try and do your presentation in the airport, I think. So, hi everyone. I'm the real Rich Welsh.
And I'm the real Polly Hickling. So we did this presentation as part of the IET Media Technical Network. I think it was in March time earlier this year. And Rich gave, if you weren't there, if you didn't watch it, Rich gave a fantastic overview of the available technologies at the time. I think Sora had maybe even that week just released some really amazing videos of some puppies bouncing in the snow. And there was a lot of conversation around how we were all screwed, basically, because AI was just going to take everybody's jobs. So today, Rich is going to show how maybe that might not be the case so much. As you've seen, there's quite a bit of work still left to do.
And we, to be fair, we had been planning this for a little while, but one of our biggest struggles actually was getting anything out of a generative AI that was even appropriate to show to an audience.
Yes.
It was, I was sending Polly some pictures going, I can't believe it's done this. And it was effectively quite...
So I think the first thing you did was that initial bit where we were going for two people stood at a conference in business wear.
Oh yeah, that's right.
I was unable to be wearing business wear without wearing very low cut top. And
then we tried swapping that to like a space uniform thing, knowing that that was coming later. And the amount of times I had to like play and tweak with it to make it not be like I was just in like a t-shirt and you were in like some sort of like jumpsuit, like
I mean,
PVC
I'm wearing a jumpsuit,
well, okay, fair.
Not PVC though.
But not PVC, exactly. So there's a lot of issues still actually with the way in which these tools are making images, and that stems from the training data. We talked about this earlier, that a lot of this comes from the fact that the training data has been made with the male gaze, and that's propagating.
And bearing in mind, you fed it real data from us, so that's images of us.
Yeah, so I was trying to steer it towards what we really look like, but everything it was doing on top of that was sometimes questionable.
Yes.
So with that in mind, we're going to talk about sort of some different aspects of AI in media, and then we're going to do a highly risky demo at the end, which might get me in all sorts live demo that might get me in all sorts of legal trouble. So
I'm going to hand over to you now.
We'll see what happens. Thank you.
Thank you.
So last time I did the web session, I was kind of looking at where you can use AI, and the applications for AI are effectively at every stage of filmmaking, TV shows, streaming. And you, I'm sure, know this, that it's literally everything from greenlighting projects and assessing scripts all the way through to audience metrics and looking at what kind of projects that you're going to make that will actually work for that audience and make you the most money. And that, of course, feeds all the way back to the start of the chain. And everything in between can use AI. I haven't actually had the chance to go all the way around the show yet, but I'm starting to wonder if I'm going to see any stands that don't have AI somewhere. It's that time. You know, we had it a few years ago with cloud, a few years before that I'm trying to think, what was our big thing before cloud? Oh, connectivity was a big deal. Blockchain, yeah. Where's blockchain gone? Anyway, So, yeah, I mean, basically, you can use it everywhere. So I decided not to do like a real rundown of application areas because, frankly, you can just walk around here and see them all, and a load that you didn't think existed and probably a bunch that you think don't need to exist. What has happened in the last few months since I did the last talk is that actually the quality of the output from a lot of generative AI has got a lot better. However, it's not easy to do. It's highly dependent on things like prompt engineering. I'm sure you know this is the art of, giving a tool the natural language prompt to make an image, and doing that well. But the quality, undoubtedly, if you get it right, is incredible. I think that picture, I don't think anyone would be like, no, that's generative, that's not real. You wouldn't pick it out. And so similarly, and as Polly said, when we last did this talk 6 months ago, the Sora had just released a load of their videos of what they could do in Sora. Now Sora is still not available generally. They have red team availability, which is a very controlled kind of beta where they're letting people play around with it, various creatives and also technology people and ethics people to see how they handle releasing that tool to the public. And as we've seen by using some over the last week or so, that's valid, that you have to be careful. You can't just pretty much hit go and hope. But the quality of videos coming from a lot of tools now is a lot higher. So all of these are generative from text prompts. I don't think you'd question if that shot was in a movie, like a Batman movie or something. And, the food, the movement's a little bit weird, but it looks pretty real. The shot with the sort of selfie at the top looks pretty good. There's maybe a slightly unnatural movement. And of course, the tiny puppy is deliberately incongruous, but it also looks very real. And none of these have come from Sora. So this was the kind of stuff we were seeing from Sora 6 months ago. And in fact, even today, the quality of stuff that we're seeing is around that. And this is coming out of other tools now, like Luma and Flux and so on. So there are lots of tools out there, and I just remembered that you asked me to do a slide at the end showing it with loads of web links, which I haven't. But I'm happy later on to help, maybe we could publish something where I can give you links to all of the tools, and you can go and have a play with a lot of these yourself for free or very little cost. But as you just saw from the little sort of experiment we did pretty much like yesterday and today, it's actually hard to get to this level of quality. And I have done other sort of prompted videos which have been pretty good, but these are, and you should always bear this in mind when you see these types of video, they're heavily curated. So they've been generating videos and gone, that's the one we can put on the front of the website because it's the one that looks great. So for every one of these videos, there are going to be hundreds, if not thousands, of kind of failed attempts to get there. So it's still, whilst we can do this with generative AI, we're still not at the point where it's just doing this freely. And as you can see, I'm no Steven Spielberg myself, so that was probably the most cringy intro video I think I've ever seen, but we thought we'd show it anyway. So I talked last time about large language models versus machine learning, because that's the big kind of topic. So a lot of what you'll see when people are talking about AI are built on top of large language models from people like OpenAI and Google and so on. And machine learning is really the kind of the nitty-gritty of AI. And, up till recently, we've kind of avoided using the term AI to umbrella over things like machine learning, deep learning networks, because those tools have been around a long time in lots of different application areas. However, because AI is now the buzzword, we're just umbrellaing everything under there. So machine learning tools are very efficient. They're trained to do a very specific thing. For instance, like face recognition in your phone. And these days, that's like embedded on an AI chip in the phone. So it's running AI locally, but they're very, very lightweight. We'll come back to some more about that in a minute. But the biggest difference, obviously, with a large language model is it requires huge amounts of compute resource to make. It's out of reach of most companies and certainly any individuals. To build it, you need millions, if not billions of dollars, just because of the raw power that's needed to get to the level of the current kind of state of the art. whereas anyone could build a machine learning tool or a deep learning network on their laptop. So, that's kind of the practical kind of where the rubber hits the road, and you'll see that around the show as well. People's own algorithms that do certain things like tracking, sports players on a football field. They're not going and getting large language models off the shelf to do that. They're building tools themselves to do that specific task. So really, it's not that much of a fight, and we'll talk about actually how they can play nicely together in a little bit. So LLMs are getting so large language models are getting larger. So the current this is roughly up-to-date information. Some of these numbers are speculative, so feel free to take pictures and use the numbers, but don't quote me on this, because GPT-4, OpenAI have not said how many parameters are in there, and I've seen estimates up to 8 trillion, but I don't think that is the general consensus. And there was a couple of trade shows that they talked at that they sort of accidentally hinted at how much it is. So they're all around 2 trillion parameters, which is kind of a meaningless number, but it tells you that basically the deep learning, or the neural network that is the large language model is sitting on is massive. It's just fast. So what's interesting about it, they seem to have kind of topped out at the moment. I don't know, they may get bigger. But this comes down to the problem that I mentioned just now, which is it's the compute resource you need, not just to build them, but then to run them. And so all of these models are only available in the cloud because you couldn't run these locally, not in any reasonable amount of time. And then other types of generative tool that come off large language models. So for instance, diffusion is a common model for making generative image. You can run that locally on your computer, but you will wait a long time to get one image. And so typically anything that uses large language and then something else will always be run in the cloud for any practical implementation. What's interesting though is that there's Gemini Ultra from Google is around 2 trillion. Gemini Pro, which is also a current release large language model, also from Google, is only 180 billion. So it's less than 1/10 the size. So why would they bring out another model that's like nowhere near as big as that one? Well, the answer is that the Gemini Ultra model is extremely good at effectively complex tasks with multi-step tasks. So you can give it a very difficult problem in natural language, and it can step through multiple kind of iterations of doing different things to get to where it needs to give you an answer that seems coherent. Gemini Pro is a much smaller large language model, which can't do that, but it can do single tasks really, really well. But because it's smaller, it's more lightweight, so then it's something that you could run maybe in your own environment, possibly in a data center, but again, maybe locally on a computer. But the whole idea of Gemini Pro is it's for companies to go out and pick up this base large language model and then effectively customize it to do the specific tasks that they're looking to do. And that you get kind of the power of that kind of natural language response that a large language model will give you, but without the weight of something that understands everything in the universe, apparently. It doesn't understand anything, as you probably know, but it has the appearance of it. So big models, really good, but very, very expensive computationally and, in fact, in real money. So small, large language models, I think, are going to become quite an interesting sort of development over the next 6-12 months. You'll see more about that, I'm sure, in lots of places. So they're not getting larger at all, they're getting smaller. Catastrophic forgetting. Oh. Has anyone, hands up, anyone heard of catastrophic forgetting? Oh, good, right. This is your takeaway for today. Basically, it was a research paper from about a year or so ago that found that when you've got a large language model that's performing really well, you can actually overtrain it. And what happens is the new training data causes it to forget the stuff that you wanted it to do in the first place. And it's literally, it can just go off a cliff. So it becomes almost completely useless. So it's like overtraining the model and training an existing model with the wrong data once it's sort of the base model, causes catastrophic forgetting, which basically ruins it. So you have to go back to where you were. So I just love that term. So I thought I'd give you something you can take away and talk about over a beer tonight. And that in itself can also cause catastrophic forgetting, of course. So what I'm seeing now, and in fact in my day job we're doing this already for things like translation and so on, is that we combine large language models and machine learning. So we found that large language models are not always the best at translation. They're a little bit too creative, actually, in essence. They can translate into different languages, but if you want an accurate translation, actually normal machine learning models are much better at it. And especially if you're doing things like translating, for instance, news or factual programming, you don't want to be free and easy with the language used. But what we did find was that large language models can then treat that afterwards, and it's quite good at, for instance, giving a little bit more of that creative kind of flavour to a translation. So, for instance, if you're translating something that's effectively a period drama, you might want to turn that into something that's a little bit more like old-fashioned language in the local language, and actually LLMs are quite good at that. And you can use them in lots of places. The most common one is summarization. Obviously, it's huge, but you could be taking all kinds of data in that's been created by a normal machine learning network, and you can then improve it with an LLM. So we're seeing that. We're also seeing LLMs building simpler machine learning tools as well. And we are seeing LLMs being used to test machine learning tools as well, which is really interesting. So the robots building and testing the robots and then working out how to make them more compelling to us. It should scare you. Well, it scares me a little bit anyway. So with that in mind, humans being a bit scared of robots, understandably, there's been quite a lot of, obviously, action over in Hollywood with digital replicas and actors. The actors' strike last year. I don't think anyone in the media industry missed the impact of that one way or another. And in the last week, actually, there's been some week and a half, there's been some legislation passed which now sort of protects actors and the use of their digital replicas in law. And also, actually, just afterwards, consent for replicas of dead performers, which is really good. I think it's important. It is a conversation we've got to have. And it's certainly something where if you're, for instance, building these kind of tools that are going to be generative, and that, by the way, it's not always going to be like silly videos of fluffy dogs and people on planets, alien planets. You could, for instance, use generative voice because you want to insert some dialogue into a movie. You need a character. You don't want a voice actor necessarily, especially if you're doing something very quickly or in a low budget sort of situation. But the people whose voices were used to train that voice also obviously have rights. And so, that's something we're seeing now, like the contracts being written for people to actually come in and record voice simply so that that voice can be used to train a machine learning model. I'll just say this because, we're friends, right? These models, it's very, very difficult and it's quite opaque on what data they have been trained on. And some people in the room are going to be people who are from content owners and creators. And it's pretty easy, even when they put guardrails into a generative image, for instance, to actually break through those guardrails and start getting copyright material out. It's very obvious that it's copyright. You recognize characters and so on. It's quite easy to trick them into doing that. So with that in mind, where's that training data come from? I'm not saying it necessarily had to be, for instance, that it's been done by just training on a load of movies. It could be that it was a load of photographs from Comic-Con of people cosplaying characters. But it feels a little bit like that's unlikely given the quality of stuff coming out. So there's definitely question marks. And if you are working with people who are offering machine learning tools and any kind of AI really, I think the question you should always be asking them first is, where is your data from? How did you train your model? Because if they can't tell you that, then the chances are if you become a customer, it might be you as well. And you, again, have rights over your data in the same way as actors have rights over their likeness. So it's definitely something to be aware of at the moment. Training data is super important, and it totally defines what these things can do, but also where that data's come from is something that you really have to, dig into, I think, would be my suggestion. So why do we care? Well, particularly with deepfakes, obviously, especially in an election cycle, like as we are now, deepfakes are everywhere. And actually, I wrote a few stats on that as well. This is a graph that DARPA produced, the Defense Research Agency in the US. And they basically mapped kind of capabilities. And you can see down here, everything from shallow fake to deep fake, and then just Photoshop and CGI, virtual production. And then right up there, like all of that put together is what Hollywood can do. It was interesting that the Defense Research Agency pegged Hollywood right up there at the top of capability, but there you go. So they think that Hollywood can do the best job of creating a fake anything from the point of view of like media, basically. And then the actors, the bad actors are there as well. So unskilled individuals, literally your hobbyist hacker, up to nation state, and then near-peer adversary, which I will admit I had to look up because I didn't know what a near-peer was. But basically it means a nation state that's on a par with the one that's the one that's the victim and the one that's the attacker when they're on a sort of similar level of capability. So, Russia versus China or China versus US or something like that. That would be near-peer adversaries. Anyway, there you go. Not to scare you or anything, but that's... the other thing is a shallow fake. I don't know if they've really come across that term before, but this is really, and again, it was like a Defense Research Agency terminology. They basically mean like taking something that's real, not manipulating it, but manipulating the information around it. So showing you a real photo, but giving you a full story about what the context of that photo was to effectively generate the kind of misinformation from it, so it's no manipulation of any images or anything like that. And once you get into deepfake, that's where you're manipulating the images. The other thing that was really interesting from this report was basically it sits just above the ability of an unskilled individual, and it's like you don't even have to be as good at doing Photoshop as basically to do a deepfake. So, although I sort of proved that wrong a little bit with my video earlier. So, and these are just the factoids about that. I think the fact that we're so exposed to it is really interesting. I had no idea, but if you look around this room, most people you're sat next to have been effectively a kind of a victim of a deepfake one way or another, or at least being exposed to them. Politicians are top of the pile, unsurprisingly, and then celebrities are second in that kind of list of people who get targeted by deepfakes. Not really surprising, but the numbers are there. What I think is surprising is that, like, this thing, which is a general kind of look at business leadership, 1 in 4 leaders are basically unfamiliar with deepfakes. Now, I don't think that's probably true in the media industry. I think that would be a higher number of people who've got good awareness. But the reason it's a problem is because it's like corporate crime, things like phishing attacks and so on now are more and more relying on deepfake type technology in order to make spoofing more, basically more compelling to the victims, so therefore making it easier to do things like phishing and corporate fraud and so on. And then people are really bad at spotting high quality deepfakes, although I think everyone would be able to spot any I did. So that's fine. Another area that we're seeing generative move into a lot more now, and it's slightly early for this, but it's making its way in, is generating 3D. So it's either generating 3D from 2D or creating completely from zero 3D models. I think the interesting ones are sort of some progressions that you can see on the right here. The top, very, very top row of 3 things was an early model. And the picture, it was a flat 2D image, and then it's turned it into a 3D model. And what you can see is it can't really figure out what's behind the thing. So it has a bit of a stab at it, but it's not great. And the back of the sofa looks like the front of a sofa, for instance. But the models are moving on, and now they actually have awareness enough to know what the back of a sofa should look like, and therefore kind of synthesize it. And even carrying the pattern round to the back of the bear, it's not kind of right, but it's doing something that's better than like nothing at all, or just putting it in shadow. And again, the same with that sandwich with the jam on. So this is really just to say that this is the next area of development, stability, AI, all of these have come from Stability, so they're responsible for Stable Diffusion, which is a very popular image generator, but they're starting to get into 3D as well. So this is a big area. And at the sort of high end of that, particularly more sort of Hollywood stuff, we're starting to see a lot more use of NeRFs and Gaussian splat, which basically is a kind of a lightweight way to get a pretty high quality 3D model. So this is a Gaussian splat model. I mean, basically looks like you're watching a video, and there are areas in which you can see the model doesn't have data effectively, and you see it go all fuzzy in those areas. But you know, for something like virtual production, could be used in some scenarios. It's maybe not if it was going to be fully in focus, but you know, if you had the frustum of the camera set up right for a virtual production shot, you could get the part of this that you want, and it would be more than adequate for an LED wall. And it has some stuff that other 3D models really struggle with, actually. This is one of the areas where photogrammetry, more traditional kind of model building from 3D scans, can struggle with things like reflections, shiny surfaces, and Gaussian splat does a much better job of that, actually. You know, again, this is a very lightweight model, be easy to run on a local machine. You're not going to be throwing huge kind of compute resource to get this in real time on a background or something. And that's actually really a big part, I think, of like opening up things like virtual production, because you could go out and scan something with your phone, create a Gaussian splat model of it, and then use it in a virtual environment to an okay level, let's say. It's not the best, but it's not bad, and it's certainly practically usable. So, how long have we got? 15 minutes, perfect. So that's some stuff that's going on at the moment that, in the media space, and you will see pretty much everything now that you're seeing. Somewhere in there, people are using AI to help them make content, even if it's just painting a lamppost out of a shot or something like that. Those tools are literally just in all the software that we love to use, and you know, from people like Adobe and so on. So it's out there and it's being used. So you're probably struggling now to see any certainly premium content that hasn't had AI touching it somewhere, even if it's just the audience metrics that greenlit the project to do that movie or TV show. So what I thought I'd do, instead of just carrying on about that, and because you're going to get absolutely sick of AI this weekend, because it's going to be everywhere, and good luck to you on the show floor, I thought I'd do a really risky demo. So I need a volunteer. God, go on then. A customer is always a bad idea. Okay, I'm going to deep fake you, Scott. I could see Rob at the back as well. Yeah, I just don't want any legal issues. That's why I've chosen someone I know. It's not a setup, I promise you. So I'm going to, basically, I'll just bring this over here. There we go. So this is the tool I use to make those weird videos of me and Polly. Already regretting my life choices. It's very cool. Unfortunately, because of the resolution, or maybe I can zoom this out. Zoom out. Oh, it's 200%, that's better. There we go. Right, so basically it lets you storyboard. It's very kind of comprehensive tool, and this is available for free, so if you want to have a go at this yourself, LTX Studio. I'm on a paid subscription just because I was burning through so many credits trying to make things that weren't going to get me in trouble with HR. And you can create scenes, you can create characters, so we've got cast here, and there we go, there's the plucky heroes. So what we're going to do actually is create a character review, if that's okay, Scott. Yeah. What kind of? All right. Well, I tell you what we'll do actually is first thing I'm going to do is take a picture of you, and so that that's a good question. Let's try the red background. It should be able to. Yeah. Let's see if I'm going to get a picture of you and try and make it flattering. Give us a smile. That's better. Right, now I'm going to just push this over. This is why this is a risky demo. So have you been deepfaked yet, Scott?
I hope not.
Hey, are you allowed to talk about AI stuff, being, Scott, are you like banned from it? Should you even be on the stage now?
I don't think I'm doing anything wrong, am I? I've got some of my Italian colleagues somewhere. They might know better.
So, I mean, do you see this stuff? I'm just going to interview you now while I'm doing this. Do you see this stuff kind of prevalent in your day-to-day, like deep fakes and?
I do use it for things like if I need to do a summary of a company or a product, I'll use it for that. I'll always put the prompt in there saying how I generated it. I have some personal projects where I use certain programs. Suno's a fun one for making
Music.
nice little ditties.
Yeah. Oh, we haven't talked about generative music at all, actually, which is interesting. I'm just going to pull this over here because it'll be quicker just for 1 second while I get the picture of you off the interwebs. So what we're going to do basically is create a character. So also what you're going to need to do for me now, and I'm going to ask for suggestions from the audience, we're going to need a scene and a setting, and we're going to need a shot description, and we're going to need a character description. But I might let you do that since it's you that's going to be deep faked. I don't want you in the hands of...
I'm not precious.
All right, well, we put you in the risky hands of the audience then, in that case, and see what happens. Hopefully nothing too terrible.
As long as it improves me, I'll be happy.
All right, well, we'll see what we can do. We might call the character a better version of Scott, but that seems rude, but I've said it now, so it's too late. Right then, so here we go. Right, this is never going to work. By the way, just like full disclosure, I saw someone try to do this, not in this software, but pretty much this exact demo about 6 months ago in another conference, and it didn't work. It completely didn't work. Right, what are we going to call you? Scott.
Yeah, Scott.
Right, Scott. Essence. Brave Protector of the Weak is the example, but yeah, superstar engineer and media technologist. I mean, that does sound like you, but let's make it more interesting. So can we
Let's make it true.
Make it true? Yeah. Well, what are we going to... Baby Guinness loves Baby Guinness.
No.
So anyone got any suggestions for the essence of Scott, the character? Come on, be creative. Never what?
I've got two.
Never has a coat. Scott never has a coat. The man who never... This is going to be really interesting. A coat, because it might start rendering you without a coat. Appearance. Classic engineer. Yeah, I know. I am literally asking for it here. Clothing. This was, you can see, I don't know.
Ill-fitting?
Ill-fitting. Fitting. Bad fashion choices.
And bad friendship choices.
Bad friendship choices, yeah, I know, I'm sorry. You did put your hand up, so... can we have the audio up? Sorry, let's have a look.
On every thorn, delightful wisdom grows. In every rill, a sweet instruction flows.
Yeah, that sounds like you. We'll go with that. Perfect. Oh, look, you're a woman. Age... You don't have to tell me. 28.
45 now.
Really?
Oh, no. Yeah, 45.
28.
No, 45.
45. And there we go, apparently. All right, that's cool. The man who never has a coat. Now, I am going to face switch. Voice switch. Drag a photo there. Right, there with me. I didn't think about this bit, because I now have to get out of PowerPoint so I can go and open a window. Let's close that. Right, yeah, sorry, I didn't think this through. I should have been thinking of more banter that we could, it's always important to have bants. Downloads, doesn't...
Can I ask a silly question?
You can.
So this, what is it, LTX?
Well, there you are. Yeah.
What's it using in the background?
They don't say, but it is a diffusion model, I know that much. And I have a feeling it is actually stability, but I don't know. I can't tell you that for a fact, and they don't say, but it is a diffusion model. So we have, now, this is the bit that I thought may or may not work, which was uploading. It's in there. All right, let's see. Here we go. Apply. Ooh, I don't know. Hard to tell from here. Yeah, not bad. Your hair's nice. Have you thought of maybe that haircut? All right, let's try a little regenerate and see if we get something a little bit different. Come on the interweb. That is literally why you don't do live demos. So no, that's a weirdly female you. Go on. It's funny because actually one of the things I haven't said is anything about gender, except that it does say the man who never has a coat, so it should know. But again, you see, it's not. This stuff's pretty tricky. Prompt engineering is not as easy as you think. Ooh, hello. You look quite dashing there. Yeah, I could go for that. Right, nice. That's got
look a bit old.
Bit old. All right, well, I'll tell you what we'll do then. Let's see if this works. So there we go. This is a good example. We're going to make him 25 and see if that actually makes him look younger. And this is the thing where I found these tools to be really interesting, because you would think intuitively that should work, right? Awesome. Now you're out of Tomb Raider. Brilliant, or something, I don't know. You see, we could be here all day doing this. How long have we got?
The next one wins.
Yeah, next one wins. We're going with it, whatever it looks like. Right, wicked. Couldn't be less you, but I'm afraid that our new character, Scott, the man who never has a coat. You should be filming this. Well, thank you. You can go back down now. Or yeah, I don't need that. Right, but we're gonna try and do a quick scene, really quick, and put you in it and see what comes out. Again, I'm really asking for trouble here, so. Add a scene. Give me a scene. Oh, here we go, scene 3. Right, cool. Scene description. Oh, weather. Okay, raining. Anyone want to give me a location? Don't say a tropical beach. Amsterdam. Of course, we're in Amsterdam. Oh, and yeah, that is true actually, because I if anyone saw my post on LinkedIn, I did do a post with a deepfake I'd done of myself, and what have I done? I've just start again. Sorry, Amsterdam. Yeah, good. Okay, lighting, lightning. See if that works. I don't think it will work, but there we go. Okay, so the shot is going to be, now the good thing about this is what we can do here, it's very easy to tell it that Scott's going to be in this by going at Scott. So now we know it's going to be Scott, and we should have it somewhere in Amsterdam. At Scott does what? What does Scott do? Quick, come on. Falls in a canal. Sorry, Scott. In a canal. Whoops. I don't know if that'll help, but it might work. It's a, what do we call it? From above. Shot. Character dialogue. Ag. It won't work, by the way, because obviously. Oh yeah, no, that's actually quite good. I like that. Right, brilliant. Okay, and there we go. Oh my God, what's going on here? Let's have a look at the shot editor. Whoa, is this creepy? That is slightly you though, Scott. Actually, now I'm looking at it, it's like a creepy female horror version of you. Okay, all right, so I'm gonna do a quick generate. We're nearly there. So it's gonna give me 4 kind of low resolution gen videos, and you'll see the kind of the movement. The good thing about this actually is you see like weirdness going on. So sometimes like weird morphing, like the top right, that's weird. I mean, they're all weird. I think that falling in a canal is the bottom right is the closest, number 4. So I think that's our one. So we're going to go for that one and generate it and see what we get. Creepy female Scot falls in a canal. I'm never going to hear the end of this. We haven't got any contracts coming up, have we? Good. Yeah, no, this is the thing, of course, now it's gone off to the back end to do the actual hard work. So this is all in the cloud. So, you know, it's going to be pretty... The wait time here is not the internet at the Rye. For the rest of your weekend, it will be, but not this. So here it comes. Come on, come on. Ooh, I'm actually quite excited about this. I'll go full screen and hit play. Go on, do it. Oh, no, that's just weird. Okay, well, there you go, you see? It's as easy as that. But we did successfully, weirdly, get your face pasted onto some new horror character. I think someone's got to make that movie, whatever it is, because it looks creepy as hell. All right, so I think, am I out of time? You are. Okay. No, I don't have any more slides. I was just closing with a creepy picture of Scott. So I guess I could take questions, but we're out of time. So that's brilliant, because then I don't have to answer for any of this. So I guess with that, thank you so much for coming along and listening and bearing with me and my little weird experiment. And I hope you got something that you can take away with you that is new and you've learnt something. And if not, you can come and find me afterwards and complain. Well, thank you very much.